I'd like to show to you an example of simple linear regression to describe the relationship between two variable x and y. The dependent variable denoted by y is the grade point average of the second and third year IE students during their first semester of the school year 2021. I'd like to know if their GPAs in the first semester have a relationship in terms of consistency to the grades they have or they earn during the first semester of school year 2019-2020. The pairs of 44 observations are sketched in a scatter plot. Using Excel, a straight line can be shown as the regression line to show how the general trend of increasing grades this school year correspond to the increasing grades last school year. We only assume that the GPAs of the students last first semester this school year depend only on the GPAs they earn from the first semester last school year. Now, in the steps in building a statistical model, we'll be estimating the parameters of the model from the data set gathered. Using the data analysis tool in Excel, a summary output was generated. Based on the result, we found that the SLR model or equation is y is equal to 2.46 plus 0.25x. The intercept parameter is equal to 2.46, which means that regardless of the grade input from the first semester of 2019, the second and third year students of industrial engineering of XU have an average GPA of 2.46 during first semesters of school years 2019-2020 and 2020-2021. Well, the slope parameter tells us that for every input of GPA earned by a second and third year IE student lasts 2019-2020, there is a 0.25 change towards their average GPA in 2021. Let us recall that the standard error of slope is important because it shows the existence of linear relationship between x and y. So from the confidence interval given in the summary output, we may say that we may be 95% confident that the true slope of the regression line is anywhere from 0.03 to 0.48. Let us test whether the slope parameter, denoted as beta 1, is equal to 0. We conduct a hypothesis test if there is an existence of a linear relationship between the GPAs of the second and third year students last first semester school year 1920 and first semester school year 2021. So the null hypothesis, that is HO, is mathematically expressed as B1 is equal to 0 or slope is equal to 0, which is hypothetically stated as there is no linear relationship between the GPAs of the students last first semester school year 1920 and first semester school year 2021. While the alternative hypothesis, that is H1, is mathematically expressed as B1, which is not equal to 0, or slope that is not equal to 0, which is hypothetically stated also as there is a linear relationship between the GPAs of the student last first semester school year 1920 and first semester school year 2021. Our statistic test is t-test or f-test. In simple linear regression, the f-test is equivalent to the t-tests. Since the p-value of the slope parameter is 0.0298, that is less than the significance level alpha of zero point zero 0.05, having a t-stat value of 2.25, we reject the null hypothesis that says there is no linear relationship between the GPAs of the students last first semester school year 1920 and first semester school year 2021. Therefore, we say that there is a significant evidence that there is an existence of linear relationship between the GPAs of the students in both semesters. As shown in the summary report, only 10.75% of the variation of y is explained by x. Since the coefficient of determination is so low, predictions may be poor. We are now at the third stage of the analysis of a simple linear model, examining the residuals and testing the validity of the model. Based on the residual plot shown on the slide, heteroscedasticity does not exist since residuals appear random with no pattern, which means that we can use the model for prediction. However, in the normal probability plot, it shows that the errors are non-normally distributed. Therefore, there is also an indication that the model may be inadequate to be used for prediction. Based on the steps of building a statistical model, in my example, I should go back to step one. For presentation purposes only, if I had a good model based on the residual analysis, I can use then the model for prediction and determine the prediction interval as well.